Hey everyone, welcome to another episode of Tiny Experiments. So here what we're going to be looking at is various ways that you can chain LLMs in Ollama and some interesting experiments you can try out. I've got 10 experiments. They're not quite as tiny as the first week's tiny experiments, so we're getting a bit more confident here and making it a little bit larger. I think these probably lend themselves well to maybe, picking an experiment or working through them in order and then spending a day playing around with the experiment and then moving on to another one. So I'll just go through these, explain basically what they do. I'm going to upload the code to my GitHub. I'll include a link in the description as usual for these videos. And I'm just going to talk you through, give you some idea of what these do. You can see we've got some output here. I've had to pre-run all of this because in total I think all of these experiments, if you run them end to end, take about at least 30 minutes. I'm not running on a particularly fast machine. I don't know what machine you're going to be running on it. The prerequisites for this are going to be Python and Jupyter notebooks, and you will also need to have a number of libraries installed because they're not libraries that are in any distribution of Python as it comes. So any sort of batteries included distribution, they wouldn't be in that. And I'll point out as we go along which ones you need, but just to clarify, every single experiment requires the Ollama library because we're abstracting away the request by using the Ollama library, specifically the chat function in there. So it just makes things a little bit easy. We could write this out in long form using something like the request library, do it that way, but we're going to give ourselves a bit of something to lean into here, something to support us, and we're going to use the Ollama library for that. So yeah, you have to run that, or if you're running these individually, obviously include it at the head of the code. All of the functions do multiple things with side effects. So this is not supposed to be an exercise in good functional programming, far from it. The point with this is all the experiments are contained and abstracted away within mainly a single function. When you get to the end, you'll see there's some with multiple functions, and that's basically because of what it's doing. But generally, everything's inside of a function, and then we just call the function to run the experiment. We might call the experiment multiple times as well with certain examples. So the first one is, again, just to clarify as well, I know I said it at the start and it's the title, but yeah, all of these we are chaining LLMs in some way. So with this one, there's two parts to this. There's a summarizer and an elaborator. So we're taking, a reasonably long description here, piece of text, and we're doing this interesting thing of summarizing it using one LLM and then elaborating using another. So we're making it small and then making it large again, and you can get some interesting results when you do that. So it's definitely something that's worth playing around with. And you can rephrase the companion text in the prompt. You can see we've got the text coming in. It's going to slide into this bit. This is the whole prompt. And we're using, as I've said, the Ollama chat function to send that, get a response, send a request, get a response. You can see the models going in. We've hard coded a lot of stuff here. Again, these can be refactored to make them more flexible and more relevant for in production use, but this is purely not in production use, and we're just using it to experiment with some different concepts and then hacking code around if we feel so inclined. Oh, one other thing, of course, it's a given here. You will obviously have to be running Ollama with the relevant models installed. I think for most of these, we're just using 5.3 and Llama 3 all the way through, and they're going to be chained in different ways. So we have our summarizer, we have our elaborator. So we're using 5.3 as our summarizer, we're using Llama 3 as our elaborator. Again, you can experiment with different large language models in Ollama, just based on what you have or what you're interested in, or what ones you might think are better suited for summarizing, and other ones that are better suited for elaboration. And you can see here for the elaborator, what we've done is embedded here the summary inside of that. The following is a summary, and then this bit here. So it's sandwiched in between those two. And then it's going to print out the elaborated response. So here's our test down the bottom. So yeah, this is our, we're not reprinting here. Yeah, we're not, I don't think anywhere here, actually reprinting the long form text. We're only showing the results. In other examples on here, you'll see it will sometimes print out the original text if it's relevant. So we're going straight into the summary of this, and then we're going to elaborate on the summary. So we basically asked it, or the original text is about foundation models and fine-tuning, few shot, zero shot, LLMs, GPT-4, those sort of things. And you can see how that's summarized that, and we can see how it's been elaborated on the summary. So it's not elaborating on the original text, it's elaborating on the summary of the original text, both using different models. But we could have chained the same model if we'd wanted to. So yeah, lots you can play around with here as well. And again, you know, clean this up, separate stuff out into, you know, their own little functions and helper functions, and, you know, basically pass in values rather than hard code them inside of the function, and all sorts of interesting things like that. Second experiment, very, very simple RAG, retrieval augmented generation, just for documents, if you like, in inverted commas, because they're very small documents. So we're just going to, and this again, we're doing this all inside the function. Again, you might probably want to separate this out into different bits. So for this one also, we need to use this library, ChromaDB, because we're going to be creating like a little database to store all our documents. So we define our documents, we're going to create a ChromaDB client and collection. You'll notice here we're doing embeddings. So what that consists of is taking our text and producing, very simply I suppose, like numerical equivalents of the text. And you may have come across embeddings before, and it's something you can look up. I'm not going to try and explain embeddings in this video, but they are, in a nutshell, numerical representations of data, often used in machine learning and NLP. And instead of storing words in documents as raw text, you're converting them to vectors. So this play around with that, and it actually uses a specific model which you'll need to have in Ollama to do that. So you need to download that before you use it.
So we're going to add documents to collection. We're adding the embeddings in there. And we've just got some feedback saying, either the document's been added or it actually already contains the documents. We then embed the query, so we convert that into some sort of numerical representation, because we've got a number of queries here. And then we're going to search through the relevant documents and generate response using Llama 3 with context. So what's happening here is we've got all the data inside this database with the embeddings, and then we're issuing a query. And the idea is that what we should find is that it will only answer questions. The answer can only be based on what's inside of the database and not outside of it. And we're simply using Llama 3 as a control system. You can see here. So it's taking the query, taking the documents and sort of looking at the documents and comparing it to the query, but only within those documents. And we'll see what happens when we ask a question which it doesn't know from information inside of the documents. Okay, so it's important to just clarify that. So we're not asking Llama to search inside of itself. We're asking Llama to search inside the documents. Okay, so what's the capital of France? So you can see here we've loaded up our documents. According to the context, the answer is Paris. So it's going to go through the documents, look to see if the answers are in there. Eiffel Tower. There's a good deal of repetition here, just to show you what happens if you sort of attempt to, there's a mechanism in here which just checks to see, have the documents already been added. So it's attempting to add the documents each time the question's asked, but the documents are already there. So again, you can play around with this. If you don't need that, remove it. If there is a reason why you want to augment the documents or play around with them in a certain way between questions, then you can hack around with the code and experiment with that as well. Eiffel Tower is located in Paris. What's the highest mountain? Mount Everest. And again, these could be wrong, but they're right against the original data. Yeah. So now we ask a question about who painted the Mona Lisa. So it's trying to search through and find, you can see here as it's going through, what it's also doing is it's looking for the relevant documents for each one. So it's trying to go through and look to see, okay, what might be, the best one of these that would contain the answer. Bearing in mind we've got some embedding shenanigans going on here as well. And based on what's in here and the question we're asking, it's determined that the relevant document is the Eiffel Tower is located in Paris out of all of these. But it doesn't actually contain, even though that seems to be the most relevant document, the answer's not in there. It's not in any of the other ones either. So answer, I don't know. The context only mentions the Eiffel Tower and its location in Paris, but it doesn't say anything about art or paintings. I'm not aware of any information that would allow me to answer this question. Experiment 3, creative collaboration, idea generation and elaborator. So it's a little bit of a variant on what we were doing earlier. This time round, we've got some text going in and what it's going to do, or a theme going in, should I say, and it's going to generate a story idea in here. by doing this. Generate a very brief, interesting concept for a short story about theme, just the core idea. Until we get an idea response, and the story idea is in the content of that response, in the message content of that response. And then we're going to take that story idea and plug it into a story prompt based on the following core idea. Write a very short, engaging story, 2 to 3 sentences. And then we have it. So first one's a lost ancient artifact. Second one's a futuristic city where dreams are shared. Our ID generator uses Phi3. Our elaborator storyteller uses Llama 3. Again, we could use different LLMs we might have access to. We could use the same one both times if we wanted to. And you can see here's the result of doing that. So story idea. And then we've got our expanding on the idea. Interesting, it's got this here. Detailed instruction, advanced level. Just looking to see. Yeah. So expanding on the idea with a short narrative, a short story, and then the other one, which was a futuristic city where dreams are shared. Experiment 4, self-correction loop. Again, we could break these down into different component parts, do separate functions for them, but we just encapsulated everything, abstracted everything into a single function, which just takes an initial prompt and then does a number of things. Does a generation, does a critique, does a refinement. So for the generation, it's got this right short paragraph about the benefits of waking up early. So it literally is just putting that in as a request, getting a response back. Then it says, here's a bit of text, which is the generated response from the previous step, and asks it to critique based on this criteria. The critique comes back, the response comes back, and then here we've got the refinement. So it says, here's a piece of text. So generated text. Here's a critique and suggestion for improvement. So there's the critique. And then rewrite the original text incorporating this specific suggestion. Again, we're using here Llama 3 into Llama 3 into Llama 3 again. So we're actually chaining Llama 3 here. So it's all the same model, but we're just chaining them all through the same model. Initial generation, there's our initial text. There's the critique. And there's the refining text based on the critique. There you go. Experiment 5, role-based Q&A. Simple keyword-based routing. So what's happening here, this is an interesting thing you can play around with, is based on what it's being asked, actually routing through different LLMs. So we're using Llama 3 for code related, we're using Llama 3 for creative, and then anything else we're going to use Phi3. So it's looking for certain keywords. We've hard-coded these in. So the first one, if code's in there or programming or function, then use Llama 3. If story or creative is in the original prompt, then use Llama 3. and then if it's anything else, use phi3. Now we could combine these together. They're actually the same model, but I just did this to keep it simple for the moment. But you can play around with different models here. You might think, oh yeah, I know a model that's really good for creative. Let's use that instead. So yeah. So you could have like 2 different models and then a default. And there's the prompt. So for the programming one, it just says, as a programming expert, answer the following. As a graduated response to the following. And then general question, routing to. So it doesn't try and give any additional instructions to sort of shape the answer or to augment the original question for the final one. So write a very short very short Python function. So that's going to go through dispatch this one. Tell me a very short story, mention your story. It's going to dispatch this one, and then what is the capital of Canada is going to be dispatch this. Now again, we could encapsulate these in other functions and actually call the functions. So again, you can refactor this code to make it more better. I was going to say, just make it better and maybe make it more Pythonic. Yeah. Okay, so you can see how it's done here. So we got some routing here as well, just almost like debug code, just to give us a clue as to what it's trying to do. So question seems co-related, routing to Llama 3. There we go. Question seems creative, routing to Llama 3, because in R1 we're using the same one. And then general question, routing to phi3. There we go. And we could basically tweak this a little bit for the general one, maybe. Maybe we could tell it, keep it succinct or something. Experiment 6, A/B testing responses. So I think I've touched on this before in a previous episode, not necessarily a tiny experiment, but this is maybe where you want to compare and contrast a couple of models. So we've got it going on in the same function. So we've just got this, the 2 models, and it's going to get a response from the first model and then get a response from the second model, and then just do a quick thing of showing us the first 100 characters. And we could add some sophisticated comparison here if we wanted to. Keyword presence, sentiment, LLMs critique. We could do some what do they call it, entropy shenanigans, and look at other things to do with embeddings. So I'll leave that up to people to experiment with. Yep. And we've got one on describe a futuristic city with flying cars. Now the other thing with this is what we're using here is you'll notice that the function call has defaults in it. So I can specify certain models, and because I really wanted to keep things simple and just use Llama 3, Phi3 and that embedding model, that's why I'm sort of sticking with these all the time. But you could put different stuff in here. If you don't put anything in, then obviously it's going to default to these. So yeah, that's the describe a futuristic city with flying cars. Model A, Model B. And then there's just the comparison section here. So it's just taking the first 100 characters, just so you can see a side by side of how it actually starts. But again, you would probably want to do something more elaborate. And then quantum entanglement, same thing. Model A response, Model B response, and then comparison. It's done a basic word count here and the total number of words. Very basic. Yeah, nothing too elaborate. I wouldn't say it's super accurate way of doing it, and you might want to clean that up. Experiment 7, content moderation safety filter. So again, pretty straightforward, very basic. So we have LLM1, content generation, and then we've got a moderator. So we're going to feed it some request to do stuff, and then we're going to use the other model to moderate it in some way. So the moderator just has this prompt where it says, review the following text for any appropriate offensive or harmful content. If it's safe, respond with safe. If it contains inappropriate content, respond with flagged, and briefly explain why, suggesting a safe alternative if possible. And the text to review comes from our original generation, and the original generation is simply based on this user input that's been passed. So we're going to test with a potentially benign input, and then we're just going to do something pretty mild just to show the moderation attempting to work. Okay, so write a frustrated rant about bad drivers. So our poem about a cat, very nice poem about a cat, safe. And this text is warmly affectionate towards cats and celebrates the bond between a cat. Okay, so on. Content deemed safe at the bottom here for that one. And then we've got our other one. So we're writing a frustrated rant about bad drivers. Moderating result flagged. The text contains aggressive language towards specific groups of drivers, generalizations about teenagers driving recklessly, and so on. Yeah. Okay. I'm just looking here to see what have we got. Where's the safe bit gone? Action required. Point 3, moderating the generated content. Oh, here we go. Yeah, moderating. There it is. Oh yeah, so there's our prompt from the fact that it's been flagged. So we get sort of continuation here. There we go. So again, something interesting to play around with. You know, experiment with different models, experiment with different prompts, maybe refining the moderation prompt a little bit. Obviously, experiment a little bit with the output, make things a bit clearer as to where certain bits start and begin is always helpful. Experiment 8, persona-based dialogue. So here we're using the prompt and actually sticking the persona in that. We're not using for this like a separate system persona as well. We're just doing it all through the actual content. So Llama 1, LLM1, persona generator, Llama 3 to create detailed persona, and then we use the persona response in our request to the second one. But it's actually part, again, as I've said, just to reiterate, it's part of the prompt. It's not a separate system prompt. So there's our original persona prompt. Then it takes the response and plugs it in here. You're to act in the following persona. Now respond to the following user query. So it's taking in the user query. So there's two bits here. There's gardening, which is the topic, and that's used to fill in the blank here for the persona prompt. And then there's the actual user query, the request there, which is putting in down here. And then that's it's all sort of being wrapped up. And so here again, we can mix and match these. So we, use the same model, different models. And you can see the response here. Generating a persona. Background, typical tone. And then advice style. See, it's quite detailed in terms of the different, you can see that. Don't forget to scroll down on these. So this here, this is all our persona. Yeah. And then that's being plugged in, and then there's the persona's response. And then we got the other one about space travel. Aurora Rory Thompson. What was the other one? Aurora Rory Greenleaf. Okay. Interesting. And so for that, background, personality, and there's the response. And then experiment 9, we've got query expansion, reframing. So another variation on this, take one thing, ask it one thing, and then do it something else, either reframe it, expand on it, those sort of things. So there's been a few of these now, but they're interesting things to chain. So we're going to take the original query and reframe it in some way. And then sort of re-ask it. So, or sort of expand on it, should I say. So we got the expansion prompt, and that goes into the this sort of detailed response. Our final answer, if you like. So the user has asked the original query, which is tell me about AI, is one of them we're going to ask. This query is a bit vague. Rephrase or expand the query, and then comes back with the response, and then we plug that back in there, so we get our expanded query, and then that expanded query goes into this request. So tell me about AI. There's the expanded query that it comes back with from 5.3. Then that goes into Llama 3, and here's the answer based on the expanded query. And then there's another one there about the benefits of exercise. So these are quite interesting ones to chain, actually. So, you know, you're getting a model to expand on or improve the original question in some way, make it less vague, and then use it to answer the question. And then finally, something you might want to play around with. It's a variation on something we did earlier, the A-B stuff, but this time round, and you can see we've got a number of functions. We're having a go at asynchronous. So this allows us to do sort of parallel processing of models if there's an advantage in doing that. And that's very much dependent on what sort of resources you've got in your system. But I thought I'd include this as a final experiment so you can play around with the concept. So we've got a couple of functions here just because of the way we've got to run the asynchronous stuff, and also the fact that we're running it inside of a notebook, Jupyter Notebook. When we come to call it, I just put this in because it's slightly different if you're not using Jupyter Notebook, if you're using Python, just because Jupyter Notebook is already running some asynchronous stuff. So if you try and do it a certain way, the same way you try to do it in, say, just regular Python as a script, if you try to do that way in Jupyter Notebooks, you get an error message about it's already running, I think, an asynchronous process, something like that. So yeah, just to point out, it's a slightly different way of doing this if you are running in just straight Python without a notebook. So here we're having to use the library to be able to do this. Again, we're just using a couple of models, and easier probably to see what's going on if we look at the response. So the idea here is what we're trying to get it to do is when it runs the models, it's doing them simultaneously rather than one after the other. And again, you have to play around with this on your system and have enough resources for it to actually be able to do that effectively. So explain the concept of recursion in programming in a similar way with our prompts. We're generating the response from using two LLMs, and then we're actually scoring the response using Llama 3. So we're generating the responses from Llama 3 and Fire 3, and then doing some sort of scoring. And the scoring is very simply just saying, here, rate the following response to the prompt, and then feeding the response to the prompt on a scale of 1 to 10. So that's our scoring prompt there. Don't know, actually it's not always great to see everything in notebooks. Anyway, yeah, it goes a little bit further. Provide only the numerical store. So we're trying to nail things down a little bit here. And then we're going to try and extract that number from the eventual response. So generates response, scores the response, and then we get our results summary. 9 out of 10, 8 out of 10 for the 5-3, and then comparing the results and saying, which one was higher than the other. And then the haiku one, 9 out of 10 and for Llama, and then 8 out of 10 for 5-3. And we're showing a little bit of the response as well, and you can play around with this in a lot more detail, expand out the amount you're showing, and then play around with the various components here. You can see there's a number of sort of parts to this in addition to just the original request. So again, something to play around with, experiment with, kick the tires on. So hopefully this was useful and will help you explore some different concepts in large language models. As I said at the start, in order to run this, you need Python, you need Jupyter Notebooks, you need Ollama running locally, you need to install the Ollama library and any other libraries for the individual experiments that I had. So ChromaDB was one, the asynchronous library was another. And then also the models that you want to use, because there's no pre-checking of the models here like we've seen in some experiments I've done, where if the model's not available, it'll download it. With these ones, the model's expected to already be there, so you need to make sure you've got access to that. And for these experiments, if you remember, it was basically 5-3, Llama 3 are the two main models, and then for a part of that, this where we were using embedding to embed numbers, we needed to use a model to do that, the nomic embed text model, so you'd need that as well. So there we have it. Thanks once again for watching. Bye for now, and I will catch you in a future episode.